then let's see.
No, no. Not available. Not available.
No one will then point that. Psychology.
Oh, I know, yeah.
I want class.
Sir will know what it is.
Yeah. All the others will be.
Yes, please. Straightforward. Then you post your way here. Yeah. Everyone should respond. Then we will see within 1 hour how much people will do. Right. Morning 7 a.m. Maybe here I will should drop it. 7 a.m. start.
20,000 rupees budget bed. Who will make up a store? 7 how to do
I will teach here.
Okay.
I will teach.
I don't need dinner, breakfast, and lunch.
Week10 come.
Hello? I'm out. Wait for till 6:05 and then we'll start the session.
No.
Okay, I have shared the link for the questions. Can someone just check and let me know if questions are accessible? I hope the questions are accessible. So we'll just go the usual way. So I will share some questions on the screen, and you can present. You can note down your answers to those in the chat messages. And if there is any discrepancy, I will cover the solutions for those questions. Yes, the answer for the first question is correct. So the question says identify the type of ambiguity or linguistic issue in the sentence, and the given sentence is the chicken is ready to eat, and in this case the sentence can sentence can be interpreted in both ways. So in this framework of the way the sentence is framed, it can be interpreted in two different ways, and the structure of the sentence itself is creating the ambiguity. That's why it's a structural ambiguity. The next question is what is the Levenstein distance between the words kitten and sitting? So this refers to the minimum number of insertion, deletion or substitution operations that you need to perform on from one word to the other, so that you can convert one word to another in a minimum number of operations, out of which only you are allowed to use an insertion operation, a deletion operation or a substitution operation. So in this case, if we get the words kitten and sitting, K and S need to be substituted for first. I, T and T, they are all the same. Then E and I need to be substituted, and N is the same, and G needs to be inserted. So the three operations that we performed in this case are substitution of K and S, substitution of E and I, and insertion of G. Yeah, so for the third question, we are supposed to identify the ambiguity or linguistic issue in the sentence. So he went to the bank to fish. So here bank actually refers to the river bank, and for a NLP model to understand the context that it's not a financial institution bank but the river bank. So the same word, lexical ambiguity actually means that the same word can be interpreted in two different ways or multiple different ways. So the NLP model needs to get the proper context and understand the word in that context. So so for the third question, the answer is B, lexical ambiguity. For the fourth question, so the distance between the words drive. So Levenstein distance between the words drive and dive, it's just one letter difference, because R is to be inserted. So I'll just briefly maybe cover the algorithm as well for the recording. So we have two words. So one is drive. other word is die. So in this scenario, so the way the algorithm works is that it basically checks out how we can substitute each from one, how we can do 3 operations of insertion, deletion, or substitution. And we want to minimize the number of these operations that need to be performed to reach from one word to the other. So in this case we have these 2 words, and this is a common practice in programming. And even so, the applications for this algorithm are for, let's say, spell check, or it can also is often used in version control tools such as Git. So where we are interested in seeing what is the difference or additions that changes that have been made from one version to the other. So these are some of the applications of this algorithm. So the idea here is that now what we do essentially is we first consider this box which is a blank space. So what we are checking is to in fact this box, so to go from a blank an empty string to an empty string, the number of insertion, deletion or substitution operations that we need to perform is actually 0, because there is nothing to change. When it goes from a blank space to the letter D, we need to perform 1 insertion operation. So we have added here 1. Now to go from a blank space to this joint string of D and I, okay, we need to perform 2 insertion operations. That gives us this 2. Okay. So that gives us a 2. Similarly, from a blank, if you want to get to these 3, D, I and V, that gives us 3 insertion operations. To go from a blank to the entire word DIVE, we need 4 insertion operations. Okay, so that's how you fill in the first row. So the idea is that you are basically counting the number of insertion, deletion or substitution operations, and the algorithm is made in such a way that the last entry that you will end up at this point, that will give you the minimum number of operations required to convert from one word to the other. So we are doing it one letter at a time. So similarly, if you had a blank space and you want to replace it with a D, you need 1 insertion operation. Similarly for R2, D and R2, DRI3, DRIV4, DRIV5. That's how you get these numbers. Then to go from a D to a D, you need only a 0. You don't need any of these operations. You don't need an insertion, deletion or substitution operation. So that gives us this 0. Now to go from a D to the joint string DI is what we are going to fill here in this box. So to do that, we just need to do 1 insertion operation. So D is already common from D and DI. So we just need to add 1 more entry, and that is going to give you 1. And there is one trick at this place that the algorithm uses. So the idea is that if the strings that you are trying to match, okay, in this case we are trying to match D and DI. So if the last letter is or last alphabet of the string to be matched is not the same, then what you do is you check these. So in this case we are trying to fill okay, I'll just clear this part. So what we do is if we want to compare from D to DI, the last letter of these two strings are not the same. So what we do is we need to take a minimum of these three elements with respect to this box. So the upper, the left, the previous element and the diagonal element, and you consider the minimum of these and add 1 to it. Okay, so that is how the algorithm is framed. What that essentially means is that if you have D and DI, you don't need to do anything for the first operation, you just need to do one insertion operation, since only the last element is not the different one, because whatever has happened before, that has already guaranteed that the commonness has come out from it. So in this case, D and D, for the first letter of this string DI is the same as the D. That's why you just need to do one insertion operation. So the entry that you substitute at this place is actually 1. Okay. So similarly, if you go for next entry, so we want to substitute D with div. So in this case you need 2 insertion operations, and that can also be cross-checked with comparing this thing. So of these 3 entries, the 1 is the minimum, and to that we add 1, so we will get here 2. And similarly you can fill in for the next one. So since D and dive, only the last letter is not common, D and E, so you need to insert 3, you need to make 3 insertions of I, V and E. So that gives us again 3 value here, which is again the minimum plus 1. Okay, and similarly you can keep filling each of these, and maybe we'll complete this one just for the brevity of, for the completion of this algorithm. So dr and di, if you want to go from the string dr to di, you need to make dr to d, you need to make only 1 insertion. So that is again same as this, the minimum is 0 here plus 1. Okay, again dr to di, the last letter are not same, so the minimum is 0 plus 1 is 1. Then dr and div, okay, so again last alphabets are not same, so you need to make 1 substitution of r and I and 1 insertion of v, so that is 2 operations, so which is again done by minimum of these 3. Minimum of this 3 is actually 1, so 1 plus 1. Similarly for this dr and drive, you need minimum plus 1. And yeah, now the important part comes. So if you have dri and just d, you still need 2 insertions, but if you have dri and di, now the last alphabet is same. So if the last alphabet is same, the algorithm suggests that you just copy in the diagonal value into this next cell. So what that essentially means is you just need 1 insertion of r to get from dri to di, and essentially that 1 keeps on translating, and at the end you keep getting a 1 here, and you can fill in the rest of the entries and ensure that the answer is the same. So the answer to this question of 1, we can get it algorithmically in this form. Okay. So the next question is, what is the main goal of word sense disambiguation? So in this context, uh, the the idea is that you want to determine the correct meaning of a word in a context. That is the main goal actually. So as we saw in actually the first no third question, so the bank here, what exactly it represented, we got that from the context. Okay. So yeah, the sixth question is, which of the following sentences contains potential structural ambiguity? So in this scenario, uh, the answer is A. The man saw the girl with the telescope. So this could refer to the person saw the girl who was carrying the telescope, or it could also mean that the girl was standing far away and the man saw her with the telescope. So the both the meanings of the sentence can actually be interpreted in both the ways, and that is a potential structural ambiguity. For stemming operations, stemming algorithm. So in general, stemming is a operation that so to in NLP, when we are trying to process the words, uh, some words will so let's say run and running, they are very alike, and they are just different grammatical expressions of the same stem word, which is run. So what we essentially try to do is we truncate the affixes of the word, and that is what we do in the stemming operation. So converting word to lowercase or remove stop words or count the frequency, these are not the part of the stemming algorithm. Typically it includes truncating the affixes of the word. So answer to 7 is A. For the eighth question, so yeah, so I ambiguity that is present in this sentence is, so is about referential. So Alex saw her at the party, but she didn't recognize him. Now, the she here is actually could be referring to some other person than the her. So that is a referential ambiguity that can't be present in the sentence unless more context is not provided. Yes, for 8 the answer is C, referential. So the ninth question says which steps are typically involved in lemmatization operation. So the answer is full morphological analysis. So these two terms, lemmatization and stemming, they kind of do the same process, but in general, stemming is a more faster approach because it has a very algorithmic approach to getting the stem or the root word of the root word. So, but instead of that, lemmatization tries to get a complete understanding of the word in different contexts, and based on that, it will get to the root word. So, answer for 9 is B. For the 10th question, we are supposed to identify the ambiguity or linguistic issue in the sentence. The chair is old, so is just a statement, and it doesn't precisely tell how old the chair is actually. So that is the impreciseness in this particular sentence, and it can also somehow be considered a part of lexical ambiguity if you consider chair as instead of being it a part of a furniture, if you consider it as a chairperson in a group. So you can also mean the sentence could also mean that the chairperson is old, or it could also mean that the chair or the furniture part is also old. So this thing is actually can be interpreted, the chair word can be interpreted in two different ways in this context. So it can also be B, but for more correct way we can call this as the impreciseness A. Yeah, in some sense B can also be an answer, but we can go with either of A and B in this particular case. The question itself is ambiguous here. Yeah, so for the 11th question, what is the primary goal of a named entity recognition system? So the answer is B, to find, classify, and classify entities like names, locations, and organizations. So example, let's say an organization such as, let's say, Pepsi. So now Pepsi is just a word of that organization. It's not, and there is nothing else which is also called Pepsi. It might not be a location or a place, someone's name, but it's a name of an organization or a company. So the NLP or algorithms, they need to understand these specific names also. So that is the goal of these NER systems. Yes, so the answer for the 12th question is A. So the idea is that this sentence, "she met the professor by the fountain," has structural ambiguity because it could mean that we are talking about a person, a specific person, whose name probably we don't know. So the professor who was by the fountain, and we are referring, the sentence says that some girl met that professor, or it could also mean that they both met at near that fountain. So the sentence itself, so it need not they both could have met at a different place, or they could have met at the fountain. So either of these two sentences are completely valid interpretations. So the 12th can be classified as a structural ambiguity because the sentence creates this ambiguity of two possible interpretations. Yes, for the 13th question, the Levenstein distance between the words ball and fall is just 1, because B and F, they just need to be substituted, and it is just one single operation. So the answer is A, 1. Answer for the 14th one. So which of the following sentences contains a potential referential ambiguity? So the answer is A, actually. So it's not B. So the idea is that here they are mentioning that Sarah and Lucy. Sarah called Lucy because she was running late. So the idea is that the she that is being referred in the sentence, it could refer to either of Sarah or Lucy. So Sarah called Lucy because she was running late. So it could mean that this Sarah person called Lucy who was running late because they probably needed to go somewhere, or Sarah called Lucy because Sarah was running late, and maybe Lucy was the person who was going to drop her something. So it can either be either way, that she can be interpreted in, can refer to either of the two. So there is a potential referential ambiguity in this question, in this sentence. Yes, so the answer to the 15th question is A. So the purpose of power of speech tagging is to essentially classify a certain word and assign its syntactic categories, whether it is a noun or a verb, etc. So the parts of speech. The 16th is actually structural ambiguity. So it's the idea is that the sentence says, I saw a man on the hill with a telescope. What that could refer to is the man, so the person who saw the man with, so a person was, man was carrying a telescope, and we saw him. Or it could mean that someone was standing on the hill, and so they are far away, and the person who is seeing actually saw them with a telescope. So it could be interpreted in both ways. So that is the structural ambiguity of this sentence. So the answer for 17th question is A, 1. The distance between cat and cart is just one alphabet. So we need to do the insertion of R. Yes, so the answer to 18th question is also A. The sentence can be interpreted in either way. So she shot the man with the camera. So it could either refer to the man who was carrying the camera, or so it can either mean that she took a photo, or actually it's actually not a type of structural ambiguity. It should be framed as a lexical ambiguity, I think. For the 19th question, yes, the distance between the word plan and pan is just 1. Yes. So the answer for the 20th question is referential. The sentence says the teachers told the students that they would receive extra work. So it could either, the they here could refer to either teachers or the students. So the teachers could be having some extra work. Maybe they are telling that the classes will be cancelled or something like that. Or it could also mean that the students are going to get extra work to help them improve. So the they here could be referring to either teachers or students, and depending on the context, the ambiguity might be present. So it's actually a referential ambiguity. So answer for 21 is not C, it should be A, because the word bat here could refer to either the cricket bat or it could refer to the bat animal. So the same word could have two different meanings in this context. So without providing more in context, it can't be determined what exactly this is referring to. So 21 answer should be A. Yeah, so for 22nd question, question says the purpose of dependency passing in LLP. So the idea is to analyze grammatical structures of the sentence. Yes. So answer for the 23rd question is also A, structural ambiguity, because in this sentence the old man and woman sat on the bench. In this case, it could mean that both the man and the woman both are old and they are sitting on the bench. But it could also mean that the old man and the since it is not explicitly mentioned that the woman is also old, it could mean that the woman is not old but the, the man is old. So the old man and woman sat on the bench. So this creates a structural ambiguity in the sense that the sentence could mean that both are old or one of only the man is old. So for the 24th, the Levenstein distance between flower and floor. So we need to insert W, and E and U need to be substituted. So it's two operations only. So for the 25th is which of the following sentences contains referential ambiguity? So in this case also A, because it says John and Peter were talking and he left early, so that he could refer to either John or Peter. So it's a referential ambiguity for 25th A. So the answer for 26th is what is the purpose of chunking? So the idea is to group tokens into phrases like nouns and verb phrases. So this is more important when if you want to basically classify the subject and object parts of the sentence. So that is where this operation is. That is where chunking is used. For 27th, it can, yeah, the answer is B, lexical ambiguity. So here the sentences they are hunting dogs. So it could either mean that the the type of dogs is hunting dogs, or it could mean that hunting is a verb and they are hunting the dogs. So it's a lexical ambiguity. So the answer for 28th question is 2. Yes. So B. So we need to do a substitution operation for A and E. Then we need to insert one P. So that is the total 2 operations that we need to perform. That covers the questions for today. If anyone has any doubts, you can ask, or we can conclude the session. So the main difference between structural and lexical ambiguity is that lexical ambiguity refers to the ambiguity between words having different meanings, whereas structural ambiguity refers to the arrangement of words, the sentence itself having 2 different meanings, a group of words together leading to a different meaning for the sentence. So that is the idea of structural ambiguity, whereas lexical is just a single word which can have 2 meanings. So let's say the bat could mean object, cricket bat, or it could also mean the bat animal, which is, so that is called lexical ambiguity. Okay. So if there are no further doubts, we'll close the session for today. Okay. Sure. Yeah, thank you for attending.